Okay, let's look at the practice exam 3, problem number 2. Right? So we want to use the L'Hopital's rule to evaluate these limits. Right? So let's do that. Alright, first we have to check to see if we can apply L'Hopital's rule. Right? So plug in. So as x approaches 0, so you can see that the bottom guy, right, 0 cubed, approaches 0. Right? If you plug in 0 for e to the 0 is 1 minus e to the 0, so it's going to be 0 minus 2 times 0 is going to be 0. So you can see that the numerator also approaches 0, right? So 0 over 0, so it makes sense to apply L'Hopital's rule, right? So apply L'Hopital's rule, right? So you still have the limit as x approaches 0, right? But we get to take the derivative of the numerator and the denominator, right? Let's take the derivative of the numerator. Derivative of e to the x is e to the x, right? And the derivative of negative e to the negative x would be negative e to the negative x times derivative of that, which is negative 1. So I'm going to turn it into positive to incorporate the negative 1. Right? Derivative of negative 2x would be just negative 2. So minus 2. Right? Derivative of the x cubed would be 3x squared. Right? Then plug it in. Right? So on top you have e to the 0 is 1 plus e to the 0, 1. So you have 1 plus 1 minus 2, right? Which is 0 again. So this guy, numerator, goes to 0. And if you look at the denominator, right, 3 times that 0 square would be 0, right? So we can apply L'Hopital's rule again. So apply L'Hopital's rule. Right, so you have a limit as x approaches 0, right? Derivative of the numerator, derivative of e to the x is e to the x, right? Derivative of e to the negative x would be e to the negative x times negative 1. So it's negative e to the negative x, right? Derivative of negative 2 is 0 since it's a constant. And derivative of 3x squared would be 2 times 3 is 6, and x, 6x, right? Then plug in, right? So e to the 0, which is 1, minus e to the 0, 1 minus 1. So again, the numerator approaches 0, and the 6 times 0 is 0. So we have that. All right. So we apply L'Hopital's rule again. So I'm going to actually go down here. So I'm going to go down here so that we have more room. So another application of L'Hopital's rule gives us limit as x approaches 0. Right? So derivative of the top is e to the x. Right? There's a negative sign, so minus. Derivative of e to the negative x is negative, so I'm going to turn into positive e to the negative x. Right? Derivative of 6x is 6. Right? Now we plug in. Right? E to the 0 plus e to the 0 is 1 plus 1 is 2. Right? 6 is 6. So it goes to 2 over 6, which is 1/3. Right? So that's part A. Right, part B is very similar. We try, so x goes to infinity, right? Infinity to the 4th goes to, of course, infinity, right? Natural log of infinity also goes to infinity, right? So part A was 0 over 0. You can apply L'Hopital's rule. another example is infinity over infinity, then you can apply L'Hopital's rule, right? So apply L'Hopital's rule. We get, so we still have the same limit. So limit as x approaches infinity, right? Then you take the derivative of the top, which is 1 over x, right? Derivative of the bottom is 4x cubed, right? Then we're gonna simplify it since I don't like to have a fraction inside a fraction. So this is going to be limit as x approaches infinity. Right, x you can put it on the bottom, so this is the same thing as 1 over 4x to the 4th power because you have one extra x there, right? Then we send x to positive infinity, so it's going to be 1 over, right? 4 times infinity to the 4th is still going to be infinity, but the 1 over infinity approaches 0, right? So the limit is 0. So this one we only apply L'Hopital's rule once, and then simplification and plug in. Right? That's it. I hope that this was clear.